And now we just landed the Perseverance Rover, and you are part of the mission, right?
Yep.
So what's your role? What do you do?
Yeah, so I'm what's called a participating scientist in the mission. So most of the science team was put together in the few years before the mission launched. And then toward the end, NASA released a call for a dozen more scientists who could conduct an investigation using rover data to further the goals of the mission. The goals of the mission are to identify an area on Mars that was potentially suitable to have hosted life and suitable to preserved evidence for past life. And also to select samples that offer the best chances of recording evidence of past life for future return to Earth. And so I proposed an investigation saying, well, my expertise is in geochemistry, and so what I can do is we can look at the minerals and try to unravel the chemical details of the waters that were there. And that's important because it links to climate and it links to the capacity of Mars to host life. And in addition to that, I'm also a member of the PIXL team. There's an instrument on the rover which is called PIXL. It's actually called the Planetary Instrument for X-ray Lithogeochemistry. It's positioned on the end of the arm. And what PIXL is it's a micro-focus X-ray fluorescence spectrometer. So simply put, it produces chemical maps of the surfaces of rocks. And that's critical because although you can take a rock and say bash it up and analyze the chemistry of it as a whole, what you're losing is you're losing the information that individual minerals and their relationship to each other tell you about the sequence of events that have impacted that rock. And that's what PIXL allows us to do. So by producing these chemical maps, we can see the minerals, we can work out the timing in which they formed, and we can actually start to be specific about events that affected the history of these very ancient rocks.
Nice. So this is the rover, and I think your PIXL is one of the 26 imaging total cameras. No, 23 total cameras.
That's right.
And the PIXL is there in the arm.
The PIXL does have a camera associated with it. It's called the micro context camera. And that camera collects images taken in the visible along a couple of different colors, and then also it collects near-infrared image and UV image as well. So it provides some spectral information to help identify minerals. But those images are taken separately from the process of hitting the target with X-rays and actually collecting the map.
So that's a multispectral sort of different wavelengths,
yes.
Sort of multispectral camera.
Yeah, and that camera was developed by a team in Denmark that the PIXL team worked closely with.
Yeah, I think I've seen they have several papers on the engineering of the instrument. So with the PIXL, do you do in situ scans in the sense that the arm goes into the rock without removing it, or first you cut the rock and then you bring it inside? What do you do?
Yeah, so ideally we want to look at what's called the fresh surface of a rock. So these rocks have been sat on the surface for millions, if not billions of years. They're billions of years old, but a lot of them have been excavated and unearthed, and so they've been subject to the elements.
Wind.
Yeah, exactly. And what we want to do is grind into the rock to, if it's a sedimentary rock or another rock that can tell us about environments or water, get a fresh picture of where the minerals are. So what the rover does is it uses a tool which abrades a patch into the rock, a circular patch, and then it actually has a dust removal device powered by gas. It basically just blows the dust out of the way. And so you end up with this nice fresh surface that you can then study with PIXL. And there are other instruments on the arm as well. Sherlock is a complementary instrument that is a Raman spectrometer. So that's a form of vibrational spectroscopy where you hit the target with a laser and the mineral lattices respond to that and produce absorptions that can tell you about mineral structures. And that's very handy because PIXL gives you the chemistry, Sherlock gives you information about mineral structures. And so if you do the two together, you can get a very, very detailed look at what's in the rock.
So you can do image registration, basically. You can overlay the images and see I can get different information from different types of instruments on the
Exactly.
same scan area.
Exactly.
That's amazing. Yeah.
Yeah.
It's sort of multi-domain imaging.
Yeah.